There are many different ways you can implement a feature in Unreal Engine. In this video, we'll be looking at how you can implement custom doors so that you can make any kind of door that you want. To do this, we'll be creating a single parent door blueprint. This will be the parent class that we can create any door from. This class will include functions that allow us to open and close the door, as well as have some sort of visual and audio feedback for the player. It'll also allow us to have some sort of player interaction so that the player can open the doors themselves. Then from this single door blueprint, we'll be able to create many different kinds of child doors. So in this video, we'll look at hinged doors, sliding doors, garage doors, French doors, and at the end, I'll look at a bonus special door. I've opened up the top-down template here and created a few basic cube meshes for our doors. So here we'll have our hinge door, our sliding door, this garage door, and a French door. Now to get started for our base door blueprint, let's go ahead and go to blueprints. We'll create a new blueprint class from actor. Let's call this BP door. Go ahead and open that up. We'll add a static mesh called door frame. This will be our part of the door that doesn't move. Here I'll find the door frame, hinge door frame. Go ahead and add another static mesh for the part of the door that'll be movable. Movable door. Call it our movable door. Here we'll add in our hinged door as our example. Get this into place. Now that we have the visuals of the door here, we need some way to let the player interact with it. We'll add a sphere collider for the player to interact. We'll search sphere, we'll add sphere collision. We'll scale this up. Go ahead and add in our onComponentBegin overlap function or event. Go back to our sphere and add in the onComponentEnd overlap. So these will be what the player can use to interact with the door. This interaction system can be replaced with any sort of player interaction system that you have in your game. So this will be just an example that we have here to get the doors working, but feel free to expand upon this and improve it for your own unique circumstances for your game. With this interaction system, let's track the current door in the top-down player character. So the top-down player character will know what door it's nearby. Let's go into the top-down character. In here, we'll create a new variable called current door of type door from our BP door that we were just working on. Now we have our BP door in here. Let's create the current door, or for the current door, let's set it to private so nothing can change the current door except the top-down player itself. Now to allow the door collision sphere to access this current door, let's go ahead and add two new functions. We'll add a set door function and a second clear door function. Let's go to our set door function. In set door, drag in our current door and set current door. Here, then we'll drag our current door pin into set door, create an input. So now here we're setting the door. In our clear door, we'll go ahead, drag in our current door, and leave it blank. So there we're just clearing the door reference. Now let's go back to our door. In here we have our begin overlap and end overlap components. From these, we'll check to see if the current interacting other, so other actor, is the top-down character. We'll cast to the top-down character. We'll go ahead and do that for both cases. So when the player enters and leaves. From this, when the player begins overlap, go ahead and drag off the top-down character and search for set door. So here the BP door can tell the player which door. And this current door is this or get reference to self. Similarly, down here on component end overlap, we'll drag off from the character and search for clear door. Now we'll go ahead and return back to the top-down character. With this top-down character, we need to create an input for the player to interact with. So let's open up our content browser, top-down input actions. Let's go ahead. I'm going to just copy one of their existing ones and rename it as input action underscore interact. And going over to the IMC default, this is the input mappings. Currently, there's the click and touch for set destination in this top-down template. Go ahead and add in our IA interact. For this interact, I will just set it as the E key. You could set it for whatever you would like. Now let's return back to the top-down character. Event graph to implement the interaction key. So in here, let's search for interaction or interact. IA interact. This is our enhanced input. Open this up. From here, we will want on started. So when the first time that the key is pressed down, we'll go ahead and get our current door. We need to check if this is valid and connect that to our started pin. Now from this pin, from our interact, we can check if the current door is valid. If the current door is valid, then we can perform some sort of opening or closing function after this. But first we need to implement those functions. So let's return to the door template or the door blueprint. In here, let's create two new functions. We'll create one and call it open, and we'll create a second function called close. Now these two functions are currently empty, and we'll go ahead and fill those in a second. But let's return back to our top-down character. And in here, we can get our current door, and for now, just call open. So when the current door is valid, we'll call open. So currently this only opens the door. We don't have a closing. We'll come back to this later once we've implemented and determined what exactly we need in our open and close functions. To do that, let's return to our door, BP door, open up our open function. Now in here, what do we need to do? We can do something with the visuals, and then we can do something with the audio. And we can also track the state of the door. So that's if the door is opened or closed. We should be able to track that as well. Now here for the visuals, we'll want to have some sort of way to represent the door opening and closing over time. So let's do that through an event. Let's go back to our event graph. We can remove these base events and create a custom event. We'll call it update visuals. In this event, we'll be able to animate the doors opening and closing in any manner that we want. Now we'll have to call this from our open function. So open, we'll say update visuals. Now we'll also want to have something that can update the audio. For that, that'll just be a one-time thing. Let's create that as a function. So function, we'll call it play audio. Return back to our open and drag in play audio. These functions now, they're just empty, or these functions and events are just empty, but we're trying to build out how we open the door itself. And then next we need to track the state of the door. So our two states are opened or closed. We can do that with a Boolean. So go down, create a new variable. Let's call it is open and drag that in. We'll set it. So here open, we'll update visuals, play audio, and then set is open. We'll set that to true. Now we'll want to perform these similar steps in the close function that we currently have in the open function. So let's go ahead and copy, update visuals, play audio, and set. Go to our close function and paste it in. We'll connect them in here. So now the close function will update the visuals and play the audio, and then we'll set is open to false. Now that we have a good idea of how these open and close functions will work, let's return back to that top-down character and figure out how we're going to both open and close the door from that single input. Go back to top-down character, Currently, we just have the open function. Let's figure out a way that we can both open and close the door. Here, we want to create a new function in our door that just allows the top-down player character to tell the door to toggle, open or closed. The player character doesn't care whether the door is open or closed, and it shouldn't have to track that. Our door should be the one tracking that. For now, delete our open function here. Now let's go back to our door to create this toggle function. So we'll create a new function in our BP door. We'll call it toggle door state. Here we will pull in our isOpen Boolean. So this will come into play now that we can toggle our state. Drag off our isBoolean. We'll say if. So we'll need to perform different processing if the door is open or closed. And if the door is open, then we close the door. Now, if the door is open is false, then we open the door. Now that we have this general toggle function that toggles between open and closed without caring whether or not the door is currently opened or closed, let's go back to our top-down character, get our current door, and we'll call toggle. So we'll have that the player toggle the current state of the door between opened and closed. Next, let's dive into the inner workings of our open and close functions. So here, let's return back to this open function in the BP door. We have these functions within our open and closed functions. We have update visuals and play audio. Update visuals, this one is an event, and play audio is our function. Let's go ahead and implement our play audio function right now, and we'll keep it pretty simple for this example. We'll double click on play audio. Let's do a spawn sound node. So spawn sound at location. And here we'll set the location as the current location of this door. So actor location. Get actor location. Connect that up. And for the sound, we can choose any sound in here. Let's just do this camera shutter to see that it's working, and then later, if we forget to change it, we'll know that we're hearing the camera shutter and can override it with other classes. You can expand this kind of in any way that you want, but for here, we'll just do a spawn sound at location. Now let's go back and look at our open function. So the only thing left in here is our update visuals. So this will be the bulk of our work from now on. And this will allow us to update the visuals for all the different types of doors that we'll later create. Open up this update visuals. This is a custom event that we have. Here we'll add a timeline. This timeline will be able to allow us to control the movement of the doors themselves. We can hit play or reverse on this timeline. And drag out our isOpen Boolean and use this in a branch. So if the door is open, then we can animate closing the door. But if the door is already closed, then we should animate opening the door. Let's have our timeline be called timeline open to keep track of which direction that this timeline is facing. So when we play from start, we will be opening the door. If the door is open is true, that means it's already open. We needed to reverse it to close the door. Then here is open is false, we'll play from the start. Now we can open the timeline. In here, we'll go ahead and track a vector track. This can be our rotation. And another track, a vector track of location. This will allow us to track the rotation and location of the doors. We'll set this down just to 1 second, but you can modify this in any way you want. Let's look back at our event graph. This here is in our parent class, which will end up overriding with all our children classes. This section of code won't actually be called, but we can use this and copy and paste it into child classes as we need it to perform different kinds of animations. I'll show you that here in a second. Before we start creating the child doors, we should make sure that what we've created actually works. Compile and save everything. So let's go ahead and add some print functions into our open and closed methods so that we can tell that it's working. go to the open function here. We'll add a print string, and we'll just print out open. Copy that, go into our close, paste it, connect our print string, and here we'll print closed. Here we go. Now let's compile and save. Go to our map itself and drag in our BP door. So now let's go ahead and play and test whether or not it works. Walk over, press E, it says open, E again, and it's closed. We can toggle between open and closed. We can exit out of this. Now that we know our doors and functions are working, let's go ahead and create a hinged door. This will be our first child class. Go ahead to the BP door, we'll do create child class. Let's call it BP hinged door. Drag out our hinged door into the world so we have it. Delete the old door. Here we go. Open up the hinged door. Here we'll open up full blueprint editor and look at the viewport. The hinged door here already includes the correct hinged door model. It has our movable door that's hinged and the frame, since these are what we used in the parent door. So we can leave that alone and go ahead and work on animating this door. Open up the event graph. We can delete the preset events. We need to override the update visuals event. Open up this, not call function, this add event will event update visuals. So this will call the update visuals event in the parent. And if you wanted to, if you right click here, you can add call to parent function. If you connect this, then that means now we've overridden our parent update visuals event and then called the parent update visuals event. But if we delete this parent update visuals, now this hinged door will do nothing. It will not call the parent class's update visuals. We want to add in this timeline we made for our previous door that we created as an example. Let's go ahead to the event graph. We have isOpen, branch, and our timeline. Let's copy, go back to our hinged door and paste it in. Connect those up. There we go. Now that we have a timeline here in our hinged door, let's go ahead and open that. And for our hinged door, we will use our rotation, but we don't need a location track. We'll go ahead and delete the location track. And we need to determine how we're going to rotate this. Look at our viewport. Here we have our hinged door mesh. When we rotate it, we can rotate it with the blue, which is our Z. Let's rotate it from 0 to 160. Go back to our timeline. We'll add a new key. We'll lock our X and Y, and then we'll add a new key to Z. This one will be at 0, 0. And our last keyframe at the end here will be at 1, 160. We have a linear interpolation between those 2 points. Now, if we go back to the event graph, we can actually apply these rotations to the door itself. Let's drag in our movable door static mesh. And from this, we can call the set rotation node. Set the relative rotation, since we want to rotate the movable door relative to the default scene route up here for the hinge door itself. We could go ahead and connect this to our update function. Now to set this rotation, convert this vector3 to our rotator and keep this simple. We'll just break our vector. From our new rotation, we'll make the rotator. There we go. So now we have an X, Y, and Z. We'll connect X to X, Y, Y, Z, Z. Compile and save. Let's go into our top-down map and see how that worked. We'll go ahead and hit play, walk over to our door, hit E. There we go. We have our door opening. The next door to make is the sliding door. Back to our BP door, create a new child blueprint class. Call it BP sliding door. Now we'll open that up. Here we'll need to set the new meshes, go to the movable door. This is the sliding door. And we'll set the door frame. And we'll call it sliding door frame. We need another door that is static for the first door to slide behind. Duplicate this moving door. We'll call it a static door. Now the static door will also be hinged or sliding. We'll slide it over, put it in the correct spot. We can reparent the static door into the door frame to keep those static elements together. Go to the event graph, delete these standard events. We'll right-click and override our update visuals function. Event update visuals. We'll copy in the same example. Go back to our BP door, get our isOpen, branch, and timeline open. Copy, put those into the sliding door. Connect the event update visuals to the timeline. Open up the timeline and we'll go ahead and edit how this sliding door is animated. The sliding door won't have a rotation, so let's delete that. Now in the location, we can slide the door back and forth. Let's see how much we need to slide it in the viewport. Select our movable door, slide it about -50 to 50 along the green y-axis. Go back to our timeline. We'll lock X and Z. Add a new key to Y. This will be 0, -50. And at the end, we'll add a keyframe at 1 and 50. In here, you can animate these curves any way you want. So just as an example, go ahead and add in a new keyframe for the Y and just raise it up. That way we can change the slope on these two different sections of the originally linear interpolation. Exit back out of this timeline, back to our event graph, and change the location of our movable door. Drag in our movable door, set the relative location from the location of our timeline. Connect that to our update. Compile and save, open the town map, drag in this sliding door. Let's go ahead and test it out. Hit play, walk up to it. We hit E and E. We can see the faster section and then the slower section that we've animated as well in the door opening. Now to create the garage door. Exit out of that. Go back to our base BP door and create a new child class called BP garage door. Open that up. Here we'll need to set our movable door and our door frame. Go to our movable door, search for garage, add in our garage door. For our door frame, we'll add in the garage door frame. That's centered at 0, so let's move over our movable door into the correct location. Go to the event graph and delete these existing nodes. We'll need to override again our update visuals event. Go back to the door function. Again, copy this over, copy isOpen branch timeline into our garage door event graph. Clean that up. Now here we can control how the garage door is animated. Let's open up the timeline. Here we'll keep both our rotation and the location. Since the garage door will be doing both, open up our viewport and let's see what these will look like. For our rotation, we'll rotate on this green y-axis from 0 to 90. And then when we raise it up from 0 to 360. Let's set that back to its neutral state. Go to our timeline. For our rotation, we'll lock our X and our Z, so we rotate on the Y. Add a keyframe at 0, 0. And add a keyframe at the end at 1, 90. Now for the location, we're going to be raising it up. So lock X and Y. Our Z, we will set a keyframe at 0, 0. And set a keyframe at the end at 1, 360. Compile and save. Let's go back to the event graph and apply these rotations and locations. So we'll drag in the movable door. From this, we can set rotation, set the relative rotation, and then we can also set location. Here we'll set the relative location. Connect up these execution pins. So for this end relative location, our new location will be the location from the timeline. And for the rotation, we can drag off and split, break the vector. And our new rotation, we can make a rotator and connect our X's, Y's, and Z's. Clean that up just a little bit. Let's compile and save. Go into our map. We'll drag out the garage door and test how it works. Let's hit play. We walk over, can hit E, and our garage door opens. So we got it working. The next door is a French door. So this will be two hinged doors together in a single class. We'll open up our content browser, go to our BP door, and we'll create another child blueprint class. This will be BP French door. Open up that. Now we need to set our door frame and the doors to our correct meshes. Then for the movable door, here we'll actually have two different movable hinge doors. We'll go ahead and duplicate this movable door. So we have two of them. For the first one, we'll set this as our French door left. With the other movable door, we'll set it as the French door right. We'll drag those into position. Our doors should be able to open appropriately. Let's go to our event graph. We'll delete these nodes. We'll override the update visuals. Add this in. Now we'll go ahead and go back to our BP door, copy is open branch and the timeline into our current update visuals for the French door. Remember, we can always do something other than the timelines. You could do different kinds of animation for every single kind of door here. But just to keep it simple for this tutorial, let's go ahead and just keep looking at this timeline. Open up the timeline for the French door. This one will not have any location changes, so let's delete the location. But here we'll have a rotation for both of the doors. And these will be pivoting on the blue axis, our z-axis. We'll do it again from 0 to 160 like our hinge door. Go back to our timeline. So we'll lock X and Y, add a key at the beginning at 0, 0, and add a key at the end for 1, 160. Compile and save that. Go to our event graph, and now we need to apply this rotation for the two different types of doors. So here we can drag out our movable door and our other movable door. So for this first movable door, let's go ahead and set the rotation, set relative rotation. I'll copy and paste that. So we can also set that for our other door as well. We'll connect that to our update. We'll drag off our rotation here. I will split this and plug this into our new rotation. Connect our XX, YY, ZZ. Now for this other door that will move in the opposite directions, we can multiply by -1. And then create a new rotation vector from that inverse vector. Here we go. So now the second door will be moving in the opposite direction as our first door. Go ahead and compile and save. Go back to our map and let's test out how that works. So let's drag our French door into our world here. Hit play, walk up to our French door, hit open. There we go. We have both doors opening. Now for the last door, go ahead and make a bonus door. Right click on BP door, create child blueprint class, and call it BP sci-fi door. Here we'll go ahead and experiment with some other things that we could do. Let's go ahead and open it. We'll keep this simple door frame that we have for the hinge door. Let's look at our event graph. We'll delete this and go back to our BP door, copy in this timeline example, move it into our sci-fi door. In here, we'll have to override our update visuals. Not that our function, but we need to update visuals event. Connect that up. Open up this timeline. Here, instead of the rotation and location, let's make a door that shrinks and grows over time as it's open and closed. Delete both of these and create a new track for a float. We'll call this track size. So here in our first key, let's add a 0 with the value of 1. So 1 being our normal size. At the end, let's add at time 1, let's add 0, but let's not let it get all the way to 0, and we'll add in a 0.1. Save and compile that. Go back to our event graph, and now we can change our size from our timeline. Drag in our movable door, and we'll search for scale. We can get this set relative scale 3D. Set our update function, and we can drag our size float directly into this scale 3D vector. Compile and save. Open up the map, drag in our sci-fi door, see how that works. Hit play, test it out. Here we go, we can open the door and it shrinks. And we don't seem to be able to open it. Close, let's see why. Oh, we're shrinking the movable door, but I had accidentally added our sphere collision to the movable door rather than the scene root earlier. Go back to our BP door, drag that out to our default scene root and attach it. File and save everything. So now that is fixed for every single child class. That's one of the benefits of making all these different children class from the one BP door. That one mistake was fixed in one spot and not copied everywhere. Back to this top-down map, hit play, and let's test it out now. We'll open it, it shrinks down, we can have it grow back up. Perfect. I hope it was helpful to see how to create many different kinds of doors while only blueprinting the core functionality one time. If you like this video, please let me know, and I'll see you in the next one.